Over the past 40 years, Hakko has earned a major reputation as an international name in quality precision soldering tools for industrial and home use. Its commitment to developing new technologies in soldering systems has been fundamental to the advancement of many industries. These advancements have made Hakko the #1 soldering equipment manufacturer in Japan. And American Hakko is steadily claiming an ever-expanding share of the domestic marketplace. Why? Because Hakko's #1 commitment is the advancement and improvement of soldering technologies. And it's the Hakko product line that absolutely underscores that commitment. It's a commitment to soldering technology that goes well beyond just selling products. Our goal is to maximize the efficiency of all OEM and MRO soldering and desoldering applications. We've created this series of instructional tapes to answer many of your questions and give you valuable tips that will increase your productivity, cut down on damage to valuable components and boards, minimize failure rates, and instruct new technicians with greater ease. So let's get to it. As you know, surface-mounted components are becoming more and more common, and we can no longer afford to rework these components with the archaic methods of the past. This, of course, is wasteful and unacceptable. Today's alternative? Of course, there are those expensive, automated, high-end type rework devices. These tools are great for untrained workers who are asked to do high-volume repetitive rework, but they really don't make economic sense for the majority of customized rework applications. And considering the tight clearance on most SMT boards, there are really only a few good methods in desoldering and soldering SMT components. This tape will look at two methods in particular. First, a safe non-contact hot air or convection method, and second, a contact soldering iron with special surface mount tips. We'll be using Hakko's 850 hot air station and the 926 ESD soldering iron to illustrate these methods. As most of you know, there are three types of mounts for SMTs: the gull wing lead components, the J lead components, and finally, leadless components such as chip resistors and capacitors. There are differences in the techniques in the removal and replacement of these various components that we will point out as we move along. Let's start with desoldering gull wing SMTs with a Hakko 850 hot air tool. If your 850 is brand new, before operating, make sure you remove the pump securing screw and follow all the written instructions for assembly. The first step is choosing the right nozzle for your component. It's easy using Hakko's 850 nozzle catalog. Nozzles are determined by the physical dimensions of the component and the lead type. This quad flat pack has a body dimension of 14 by 20 millimeters with gull wing type leads at a pitch of 25 mils or 25 thousandths of an inch. The nozzle's dimensions are large enough to focus air directly on the leads. The pitch is the distance from the center of one lead to the center of the next. Nozzles are basically heat-focusing heads. They distribute hot air evenly to component leads. The nozzle never comes into direct contact with the board or leads, which makes hot air one of the safest rework methods available. Another advantage of Hakko nozzles over conduction-style tips is that they virtually last forever. Once you've determined the correct nozzle, attach it to the pipe. Then choose the FP pickup wire that matches the size of the component. Some J-lead components cannot be accommodated by the FP pickup wires. In those cases, you'll need to use tweezers or some variety of vacuum pickup tool. Next, adjust the airflow and heat control knobs. These controls, together, determine the temperature of the air at the exit point of the nozzle. Use your temperature distribution chart to determine the correct settings for both. We recommend a temperature of 600 degrees Fahrenheit as a safe starting point. In this case, we're using an A1128 nozzle for our 14 by 20 millimeter component. In order to operate at 600 degrees, we set the heater control knob at 6 and the airflow knob at 4. The larger the open area of the nozzle, the higher you need to set the airflow and heat control knobs. So if you want to set the temperature at 600 degrees Fahrenheit for the larger A1129 nozzle, we would need to set the heater control knob to 7 and the air control knob at 4. Note that a temperature of 600 degrees can be achieved by a variety of settings of the air and heater control knobs. The higher the airflow setting, the higher the heat setting. The higher the settings, the quicker the reflow. But a high airflow can be a problem on very dense boards, causing adjacent components to reflow or blowing solder across the board. If you don't carefully follow the temperature distribution chart and you set the heat control too high and the air control too low, heat can back up into the handle. Left unchecked, this would heat up and possibly melt the handle. This is often a problem with single nozzle attachments. However, the 850 has a safety shutoff, so when heat backs up, it turns the heater off, protecting the instrument and the user. After you set the temperature, flux the leads. Flux aids in the transfer of heat. Most kinds of rosin-based, water-soluble, or no clean fluxes are okay. Place the FP pickup under the lead frame. Make sure you have allowed the 850 a short period of time for the temperature to stabilize. Hold the nozzle about 2 inches away from the component for about 10 seconds to allow preheating. This prevents thermal shock to the board and component. Then bring the 850 over the leads of the component until it reflows all the solder. By applying a small amount of upward pressure on your FP pickup, you'll be able to tell if the component is loose and all the solder is molten. Be sure to never force or jerk the component. This could cause one of the pads to be lifted from the board. In the case of a J-lead component, the steps are basically the same. The nozzle is shaped differently to allow the air to flow directly to where the leads and the pads meet. With this type of component, there's a higher volume of solder to reflow, so you'll need to allow more time than you would for gull wing type components. When the component can be easily moved with the nozzle, it's ready to be picked up. For some uses requiring a more steady tool, inexpensive holders for the 850 handpiece have been designed, such as this one. Smaller caps and chips can also be removed and replaced by the 850. In this case, we will use one of 3 single nozzles. Add flux to the leads. Use a pair of tweezers to grip the component. And heat the solder and pull the component off. Note, if the 850 airflow is too strong and blows solder off the pads or heats up adjacent components, you might want to use Hakko's 851 with an airflow specially designed for these smaller components. Now that we've removed the SMT component, we're ready to attach a new one. Let's look at 3 different methods of soldering surface-mounted components. First, you'll want to remove all of the remaining solder and flux from the board. We'll do this with a K-tip on the Hakko 926 ESD soldering iron using solder wick. In this case, the optimum temperature for efficient soldering is 750 degrees Fahrenheit. At this temperature, one should move quickly to avoid damage to the board. Solder wick contains flux, which actually draws solder to it. It pulls up all the excess solder. Always stroke the wick in the same direction as the pads to avoid pulling them off. Next, remove all remaining flux with a flux cleaning solution. Now we lay down the component, lining up each lead to its pad. We add flux to assist in the reflow of solder to the leads. Avoid bumping and possibly bending any of the leads. We then lay solder on one edge of the K-tip. A very small amount is needed. First, we tack down 2 corners of the component in order to stabilize it. Check the alignment. If 75% of the leads are in contact with the pads, then the alignment is acceptable. We then paint or brush across the leads from the leg to the pad. Let's watch this close-up again. The flux assists the solder in flowing to each leg and helps prevent bridging. This method allows you to solder 3 to 6 leads at a time depending on the pitch of the component. If too much solder is applied, a problem can occur. Solder can form bridges, meaning excess solder has bridged between 2 leads. To remove a bridge, add flux to the bridge, wipe the excess solder off the K-tip, and then touch the bridge with the solder tip and lift it off. It's that easy. Finally, clean off the flux, check your component alignment, and make sure that each lead has been properly soldered. Now let's look at this same method with a J-lead component. All the steps are the same. Remove the solder, clean the flux, align the component, flux, tack down 2 corners, and check for 75% lead to pad alignment. Now, when you put the solder on the K-tip, apply it to both sides. For J-lead components, more solder will be necessary. The flux will assist the solder in reflowing under each leg. If a solder bridge forms, flux the bridge, clean off the excess solder, and bring the tip to the bridge and lift out. Again, remove the flux with flux cleaner and check for alignment and properly soldered joints. In some applications, such as R&D labs where very quick removal and replacement is desired and the operators are highly skilled, there is a method of replacing a component with the existing solder left on the pads. This method only works with a hot air tool with a nozzle that matches the component. This way, the solder can reflow simultaneously and the component will remain level as it sets in place. First, if there are a lot of peaks on the existing solder, you'll want to smooth them out. Flux the solder and bring the 850 over the area. Once again, it's important to preheat the area to avoid damage to the board. This method will smooth out the peaks of solder. Now flux again. The flux protects the solder from oxidizing. Place the component on the board, aligning it to its pads. Bring the 850 over the component. As the solder reflows, the component leads migrate to the pads. Notice how the component sets in and remains level. Then clean off the flux. When finished, check for bridges, alignment, and properly soldered joints. Solder paste is atomized solder. Its creamy texture is created by the mixture of solder with flux. Solder paste has a short shelf life, about 3 months, so knowing the volume of your rework is important in determining the amount you need to have on hand. In using this method, we repeat all the steps in removing the leftover solder and flux. We take a dispenser unit, which is designed to lay the exact amount of paste needed. Then we lay down and align the component on the paste, pressing it down into the paste. We use the 850 to reflow the solder. Remember to preheat the board and component first. We can also do one section at a time with a single nozzle. Remember to push the component down into the paste to avoid coplanarity problems. We recommend that you approach the leads at a 90-degree angle for best results. Once again, the solder in each case reflows and the component sets into position. Check for bridges, proper alignment, and properly soldered joints. If bridges are found, they can be removed by reflowing the solder with the single nozzle and running a dental-type tool in between the leads where the bridge is located. Then clean off the excess flux. This method may be more difficult with finer pitched components because bridging becomes more of a problem. Let's look at this method with a J-lead. Let's look at this method with chips and caps. Each of these methods has its own advantages. Which you choose will depend on your application and personal preference. There are other systems used for SMT components like hot wire or hot bar contact soldering systems. They don't provide the protection that hot air does, and their tips wear out more often. That can get pretty expensive over time. Hakko's Hot Air 850 provides the safest non-contact soldering and desoldering of SMT components available. With the 850, you can use the same nozzle to both solder and desolder. The process is simple and streamlined. The air source is as clean as the environment you're working in, and the 850's pump reservoir flattens out the surges of air emitted from the pump. The 850's stainless steel nozzles virtually never wear out, and there are over 30 standard nozzles available. Custom nozzles are available upon request. And with a temperature capacity of 200 to 1100 degrees Fahrenheit and a dual-action diaphragm-type pump, the 850 gives you all the steady, consistent power you'll need. The heating element is protected by quartz glass, and the thermal cutoff protects the handle from overheating. That protects the operator from injury, and safety is always the bottom line. And you can't shut it off without cooling, because its foolproof automatic cooling mode protects the heating element from the sudden shock of turning the power off. With all these features, it can run all day and never overheat. In contrast, the K-tip methods of soldering SMT components shown in this video will also work well in combination with the 850. It becomes a matter of personal preference and the type of jobs you're doing as to which you'll prefer. At Hakko, we want to provide you with the best and safest alternatives for reworking your SMT assemblies. We hope this tape has given you some insights to good, safe, efficient, and effective techniques. Thanks for joining us. Make sure you inquire about the rest of the Hakko soldering product family, all designed for ESD safe use in anti-static and cleanroom environments. The 900 series of soldering tools. They heat up fast.